All right, everybody. Our final mechanism for today, you might think is our final mechanism for test 4. Sadly, I'm saving a little fun for Wednesday, but it's less than 10 minutes of fun. You're going to learn the mechanism that's almost identical to this one. Wednesday, we're going to do this one. It's a shorter version of the one that we're about to do. And you get this. The O stays in the same spot. That's different. Then it's there, and this is called ROTF, a secondary RX as well. OTS minus is a leaving group, right? Now you see why it has to be on this test. This is where the OTS leaving group comes from. Monday, which is today, we're going to do this one. And the most reactive atom on the page there is sulfur. What's the electronegativity of sulfur? CSI are all the same. Guys, if you don't know what carbon's electronegativity is, you should leave the room. Carbon's electronegativity is what? 2 point what? 2.5. Oh, this was a very nervous moment for me just now. Because this is the last weeks of the semester, and this is organic chemistry. Okay, 2.5, C, S, and I. Sulfur and oxygen, 3.5, and chlorine, 3.0. Both numbers larger than 2.5 means sulfur has 4 bonds to more electronegative stuff. Sulfur is incredibly reactive. It's got 4 bonds to more electronegative atoms. So remind me what kind of a nucleophile an alcohol is. Do you need choices? Strong, medium, poor. Alcohol. It's already on today's videos. We already mentioned alcohols being a blank nucleophile on today's videos. Poor. Poor. Neutral oxygen. Poor. There's alcohols, carboxylic acids, ethers. They do not like attacking things because they're poor. But sulfur here is what I call hopped up. It's really reactive. It'll react with even the worst nucleophile you can think of. So the lone pair on the O is sufficient. You don't need a catalyst like we did earlier today. You'll see we use the catalyst to activate a chromium today, but this is already activated sulfur. Question. What breaks first, pi or sigma? Pi. Please show me you know that in your mechanism on the test. If you break a sigma before a pi, you get -1. Comment. Sigma broke before pi. We don't want that. We don't like these comments. What is the pKa of an oxonium? -3, -2, either one sounds good to me. That's a strong acid, right? Pyridine is an amine-ish. It behaves very much like an amine. It's a base. It's not a strong base, but we don't need a strong base. We have a strong acid, right? Please use pyridine now and not at the beginning of the reaction. We have 3 students in this room who thought it was okay to take the H off of an alcohol with a weak base. They did. They used this conjugate base of sulfuric acid to take an H off an alcohol because they saw a faster way to get to the product. But they forgot that a 17 doesn't go towards a -5. That's against the laws of acid base. So don't use pyridine to take the H off of this and go from 17 to, in this case, 10. Doesn't happen. But now you can use pyridine to grab the H off a -3 because it's strong. We're almost there. And no, the H didn't disappear. The green H, it's always been there. I'm just not drawing it. Look at the two CLs in the products, and neither one is in the right spot right now, is it? Can you tell me how to get at least one of the CLs off? While I draw SO2 gas to remind you maybe how you can get there. It won't let me draw that. There we go. There's SO2 gas. It leaves because it gets kicked off. The lone pair does what? On O minus, becomes a pi. It resonates down and kicks off Cl minus. No, S hangs around for a while. Get me to the end. I need the Cl to be on a dash, where there used to be a bond to a leaving group, on a wedge. What's that called? Thank you. Backside attack. Look at the gas that I redrew in black. Tell me what to do with the green wedge sigma bond. Make it out. There's no O in the carbon product. So clearly it has to leave. And it has to become what? Yeah, but tell me what to do with this. I didn't finish my arrow. A pi. Between which two atoms? O and S. What has to happen to the other Cl? It leaves. I would like to point out, this is a violation of a question I answered earlier. What breaks first, sigma or pi? So in 242, I make them do it this way. And then I make them do this in a separate color. But you're not ready for that. So I do accept this. Leave it in red, so you're nothing special going on here. And there's an argument to be said that this one does break off because of entropy. It says, as soon as you make that pi, then SO2 starts feeling gaseous. This is all I have to do. The Cl has to go, and I have all my freedom, my gas freedom. What's that called? Starts with an E. Entropy. That's right. Yeah, it's looking for entropy. So maybe the pi doesn't break. It sees this future as a gas, and it leaves. And that's that for that. And see you Wednesday.